What's up, guys? Coach Sepi here. Today we're going to be looking at Pythagoras' theorem. This theory dates back hundreds of years and is still used practically in GCSE maths questions nowadays in exams. This theory comes a lot in use in different situations and scenarios, and the theory is in a right-angled triangle, the two shortest sides, A and B, let's call them, the sum of the square of the two shortest sides are equal to the square of the largest side, which is called the hypotenuse. So in this example, and in the general example, it's a squared plus b squared equals c squared. And this simply means the shortest distance between 2 points, points 1 and 2, is a straight line, rather than going around the side of the triangle. Let's look at some examples. In the first example, we have been given the length of the largest side and the length of one of the short sides. So the side that is opposite the right angle is always called the hypotenuse. And the value of the hypotenuse for this case is 16 centimeters. We're going to label this triangle with sides A, B, and C. And we're going to apply Pythagoras' theorem. A squared plus B squared equals C squared. Now we've been given the sides PQ, PR, and QR. And they're asking us to find out QR. So let's substitute these into Pythagoras' theorem. We'll have PR squared plus QR squared equals PQ squared. We simply replace the letters with the actual numerals that are used in this question. Let's rearrange this equation in terms of QR squared, since that's what we're solving for. We'll have QR squared equals PQ squared minus PR squared. We already have the values of PQ and PR, so we have to substitute this into the equation. We'll have QR squared equals 16 squared minus 8 squared. And you don't need to convert this into meters. We're leaving the answer is in centimeters. 16 squared is 256, 8 squared is 64. Minus each other, we'll have 192. And finally, we need to square root this because it's QR squared. So QR squared square rooted will give us QR. So square root 192 is 13.86 and gives us the trivial answer. Let's move on to the next example. This time we have a right-angled triangle with the values given of the two short sides. This time we have to calculate the length of the long side, the hypotenuse, which in this case is YZ. Again, we write Pythagoras' theorem in terms of the numerals given. So xy squared plus xz squared equals yz squared. We have the values of xy and xz, so we substitute this into the equation. We have 3.2 squared plus 1.7 squared equals yz squared. Use your calculator to find the value of the left side, which in this case is 13.13. And finally, we square root this answer to give us the value of yz. The final answer was 3.62, and we can confirm this is correct since this is larger than both of the short sides. Move on to the next example, which is more involved. This time it's a trapezium, and it's asking us to find the length of AC. How do we do that? Well, first we have to draw a line from A to C to visualize how this looks like. And from here you can see that we formed a short right-angled triangle from A to B and B to C, with the hypotenuse being AC. Next, we go back to the trapezium, and in order to find the length of BC, we have to split up this trapezium into a square and a right-angled triangle. Since you can see through observation that BC and that line that I've drawn are exactly the same length, and we have formed another right-angled triangle from A to that point, let's call it point 1, and from point 1 to D. The length of AD is 10 centimeters. The length of that short adjacent on the left hand side is 9 centimeters minus 3 centimeters. And the length of point 1 to point D, we have to find out. And once we find that out, we will know the value of BC, and we can move on to solving for the value of the length of AC. So here we have the hypotenuse 10 squared minus 6 squared, the adjacent will give us the value of the opposite side squared. 10 squared minus 6 squared is 64. And square root this answer to give us the value of the final small side, which is 8. Now we know the value of this is the same as BC, so the value of the length of BC is 8 centimeters. So now we finally have the length of AB and BC. All that's left is to apply Pythagoras' theorem one more time to solve for AC. Let's fill out the triangle with the values that we know, and we'll leave a question mark on the hypotenuse to see that this is our target length. Again, we revert to the original triangle, and now we apply Pythagoras' theorem. So we have both the lengths of the short sides. All we have to do is find the final length of the hypotenuse, which is 8 squared plus 9 squared equals the length of AC squared. Which gives us 145. We square root this, and that will be the value of AC. .04. Okay, let's move on to a final example of a question which doesn't involve any diagram, any shapes. We have to kind of visualize this ourselves and draw it out to understand it. It says the ladder is 6 meters long. The ladder is placed on a horizontal ground resting against a vertical wall. So you guys need to imagine a ladder that's resting on a wall, and the length of the ladder is 6 meters long, and the ladder must not be closer than 1.5 meters from the bottom of the wall. So the bottom of the ladder and the bottom of the wall are 1.5 meters long, the distance between them. And the hypotenuse value, since the ladder is leaning, that will be the hypotenuse, the largest side. That will be 6 meters long. So all we're left with is the adjacent to the right angle, which is the length of the wall itself, which is essentially how far up the ladder can reach at this angle as it's elevated at. Draw out the right angle triangle with the values that we know. And now we apply Pythagoras' theorem one more time. We'll have 6 squared minus 1.5 squared, the large side minus the short side. Gives us 33.75. And we square root this finally to get the final value that we need. Which is 5.8 meters. Coach Sepi, and I'm signing out, guys. Peace.
What's up, guys? Hope you found that video educational. Now, if you want to completely transform your maths abilities and take it to the next level with both A-level and GCSE maths, I provide weekly one-on-one maths tutoring lessons on my Patreon, where I help you with any topic that you're struggling with in maths, and I coach you to completely transform your mindset when it comes to maths. So follow the link in the description for that. Check it out. Peace.